Hi everybody. Alright, so today we are going to go another step further. So Monday we did a video on simplifying a rational expression. So just taking that fraction and simplifying it, like the same idea as simplifying 2/4 to 1/2. So what we're going to look at now are multiplying rational expressions. So remember, rational expressions are fractions. So how do you multiply fractions? So let's think back, 7th grade, we really, hit that hard. So if I have like 1/2 times 2/3, we learned that you can multiply fractions straight across, so that would give us 2/6, and then we could simplify, and that would give us 1/3. But another way that we learned to do this was we could simplify first. So if we have this 2 in the numerator and a 2 in the denominator, we could do what you all love to do, cancel them out or simplify them, and then all that's left is 1/3. This is the way that we're going to look at multiplying our rational expressions. You could do it this way, but this way is going to be just, saving ourselves a step. So let's talk about what the steps are. Now you'll notice this first step is the same as with simplifying. First thing you're going to do in both fractions is you're going to simplify and factor all expressions. So you're going to factor numerator and denominator for all fractions. Then you're going to find all your domain exclusions. So for both fractions, or if you're multiplying 3 of them together, however many there are, you're going to find what makes that denominator 0 in every fraction. Then we're going to simplify any common expressions, and we're going to do that using this method. So we don't have to rewrite anything. Anything in the numerator can simplify with anything in the denominator. So this is the same as, those words I don't like, but I'll use them here. I'll write them, I won't say them. And then you're going to write one expression as your answer. Now notice, never did I write the word multiply. And that's because we don't really do any multiplying with this. We really just do simplifying, which we've already learned to do. Excuse me. So let's look at a couple examples. You'll see that this is basically just adding a few more expressions into what we did on Monday. All right, so here we have this rational expression times this one. So first thing we're going to do is factor everything. So these two won't factor, so I'm just going to rewrite those. X squared minus 1 can be factored by a difference of squares, x plus 1 and x minus 1. 3x minus 21 has a GCF, so I'll factor that out. All right, next step, find all your domain exclusions. So what makes both denominators equal to 0? So what will make x minus 1 equal to 0 is 1. So x can't be 1. Nothing will make 3 0, so don't have to worry about that. And 7 will make x minus 7 equal to 0, so x can't equal 7. Then I simplify. Anything from either fraction that's in the numerator can simplify with anything from either fraction in the denominator. So x minus 7 and x minus 7 will simplify. X minus 1 and x minus 1 will simplify. So in the numerator, I'm left with x plus 1, and in the denominator, I'm left with 3. And again, remember, this is just, if I plugged in a number for x into this problem, I plugged in a number for x into this, it should give me the same answer as long as you're not using 1 or 7. So let's look at another example. Alright, so first thing we're going to do is factor everything. X plus 3 is not going to factor. X squared minus 4 is a difference of squares, so x plus 2, x minus 2. Here, reverse FOIL, that's going to be x minus 3, x plus 2. And here, reverse FOIL, that's going to be x plus 3 and x plus 3. So then I find my domain exclusions. So x can't equal negative 2 or positive 2, so I'm going to write it as plus or minus 2, but you can write 2 or negative 2. And then x can't equal negative 3 for either one of those. So you only look at the denominator for your domain exclusions. So then, let's see, I have an x plus 3 and an x plus 3. Now, but there were two x plus 3's down here, but there was only one in the numerator, so I could only cross out one in the denominator. Then I have an x plus 2 and an x plus 2, and that's all I have. That will match up. So then in the numerator, I'm left with x minus 3. Over in the denominator, x minus 2 and x plus 3. Alright, now one thing else I want to show you. Get another sheet of paper. Alright, let's say we have this one. Let's go over one more. So factor everything. So this is just x cubed over x plus 5. That's not going to change anything. X squared minus 25 is a difference of squares, so x plus 5 and x minus 5. And here we have a GCF of x squared, and that leaves me with an x minus 1. Alright, so I do my domain exclusions. So what makes this equal to 0 is negative 5. What makes x squared equal to 0 is 0. And what makes x minus 1 equal to 0 is 1. So then I look for things that I can simplify. So I can simplify this pair of x plus 5's. But then I've got these x's over here. And so this is really what? 3 x's, and this is 2. So I can mark out 2 of those x's. And that leaves me with 1 x in the numerator, still an x minus 5. And then in the denominator, an x minus 1. You could also think about this if you have x cubed over x squared. Normally we would subtract the exponents, that's 1, and you put your answer where the higher exponent was. So that's where that x went in the numerator. Alright, so today we're going to practice with multiplying. Please message me any questions. Have a good day.